Okay, so this, all right, this is the Arduino Mega 2560 control board. This is the controller of the 3D printer. Okay, and you can see a little picture of there on the right. It's open source, and what that means is that the design of this, made by Arduino, was made available to anyone and everyone who wants to make it. Now, whenever you purchase something like this, understand you're going to be getting it out of China. The U.S. does not make these things, mostly because there's not a big demand for it, and also because, at least on the U.S. side, there's not a big demand for it. And since there's not a big demand for it, people aren't making it because you're not going to make a lot of money. So this is the pictorial of the piece. And here's the piece. This bags, I don't know if you've ever seen these bags before. These are static electricity bags. It's to prevent static electrical discharge, because high amounts of static discharge can fry a circuit board. That's not too hard to do. So if I look at this, right, I see here it says Mega 2560 R3, which is version 3. And then this red button that you can see back here, and also here, that's a reset button. That's the chip that will run all the thinking. And then here is another big piece. That's the printer serial board, printer serial connection that would allow the board to connect with the laptop in this case. And then we have a little power supply. You could run this on its own. Okay, this is something that can run on its own. We are not going to run it on its own because it doesn't have nearly as much processing power as we would need. So we're going to open this bad boy up, and then we're going to combine that with something called a RAMPS 1.4 board. So we pull this out. So here it is. Okay, the bottom side, this is what a circuit board looks like. These are little pieces of metal that are molten that are used to connect this top piece from the bottom piece to connect it to the actual board. To say I fully understand all the electromechanics and the electrophysics of this would be a lie. But there you go, Mega 2560 R3 open source, as per usual, made in China. All right, so I'm going to put this here, and I'm going to show you a RAMPS board. Now, this board is a RAMPS 1.4 board, and I have it upside down. So this is a typical RAMPS board. This is also open source. It doesn't come with a pretty box. It's just a cardboard down and dirty box. And this has some particular pieces to it that I want to point your attention to. D10, D9, D8 are things that are going to be powered. So whenever we put in, I don't know if you remember, when we put in information about the board, we would put things in that were like effect EFF or EBF. That's effector bed fan, effector fan. We have effector fan, right? That's because those are the three things that are going to be powered the most, right? Here is the X, Y, and Z sensors over here. And I mean, there's a bunch of other stuff, and we'll go through it. There's actually a map of this board that's available online. What we're going to be focused on the most right now is actually the underside. And you'll see this piece of styrofoam here, and you're like, hey, why is there styrofoam here? Well, if we pull it out, and we try not to bend anything, if you ever do this on your own. So we pull it out like this. Oh. Almost got it. There we go. There. So you see these prongs, right? So these prongs form almost like a U with a double on the bottom side. And if you look at here, there's a double on the bottom side here, and it forms a U. And if you haven't guessed it already, they are going to line up. And the way you line them up is you just line up the very, very tip of it. Don't push it in here or you're going to bend it. You line up the very tip of it, and then you lean it forward. Okay, and once you've done that, then you're going to try to squeeze it even. See how it kind of went in uneven? So, oh, I see one of the prongs are bent. And that's before me If it is bent, you could see it here. See that? See that prong there that's bent? You got to bring it back into center. I'm looking for pliers now, or something at least that I can use to make some force into it. It might have happened when I took the styrofoam off. I've done it before, but rarely has it led to a problem. So I'm just going to push it straight now. There it goes. And this one looks a little bent too. Alright, let's give that a whirl again. And taking your time with this and just kind of really lining it up and then checking for bent pieces will really make a difference here in the end, right? So I'm here. This looks and feels pretty good. I see a bent piece up here. See that? So I see I got to straighten that out. And there's really no way around it. I've never gotten a perfect ramps board or a perfect Arduino board. I think it's the shipping from China. But I mean, I don't know when they got bent. There we go. And you don't want to overbend it and overcorrect the problem. All right, so this needs to slide in better. Yeah, that's good. That's good. That's good. And you should see no space in here. No space in here. No, oh, there's a little bit of space in here. You see that? How you see a little light in there? There we go. And look how tight that fit is. I mean, it's almost like they designed it that way, and that's because they did. They designed the ramps board, the top board, to fit the Arduino board on the bottom. Now this is ready to go. And I'm going to put it back into its static electrical space here. And we're good to go. So I'm going to be testing this thing out today. I'm going to see if this thing is actually able to take in. Remember, we were having trouble with Repetier to connect to this board and have it connect. We were able to upload on the old board, but we weren't able to connect. This will eliminate whether or not it's the board. I also have a new cable. The new cable didn't work, so we eliminated that as a variable. So hopefully now with this, we'll be able to figure out whether or not it's the old board or if a new board was needed. And it was $30, so it was a nice, inexpensive solution. All right.